Now we're going to start looking at some of the reactions that fatty acid chains will undergo in order to form other structures. And the first one we're going to look at is a wax. This is a really clearish example of the type of reaction that's going on, as it really shows the fatty acid, and in this formation diagram we see that on the left, plus an alcohol, that's what's going to react with it here, that are going to form a wax, which has an ester, right? This is a carbon double bonded to an oxygen, and then it has another oxygen that's kind of stuck within a hydrocarbon chain. These R and R apostrophe or R prime groups are longer fatty acids, so long chains of carbon on either side of this ester. When we form this ester from a fatty acid and from an alcohol, we end up losing water. And this is a really important class of reaction to understand because it happens in biochemistry very commonly. We have a lot of carboxylic acids, and things get basically mounted or attached to these carboxylic acids all the time. And when we do this, water is a byproduct. We call this a dehydration reaction. This is very common in biochemistry, again, where when we break something apart, water is removed. Again, you know, those hydrogens and the oxygens, they took up bonding space. So by removing them and gluing the things that they were attached to together, we form water and then a larger molecule. This, again, is a really important thing to note, and something that's going to come up a lot in this lipid chapter as well as future chapters. And so here's our wax structure. Again, a long chain of carbon on one side of the ester and another long chain on the other, and these are both hydrophobic regions. A longer depiction of this molecule is shown here, and we use these R groups because these chains could be different lengths. Different lengths would define different structures of this wax. And so R is kind of just a placeholder for what would be, like kind of a large carbon containing side of the molecule to depict, right? It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 on one side and even more on the other. So depicting this somewhat differently can be helpful. These form protective coatings, birds' feathers, sheep's wool, it's kind of like a waterproofing wax, naturally occurring waxes. This is another use of lipids, which even more importantly shows how we combine a fatty acid into making an ester, which we're going to see quite a bit more moving forward. Waxes can be hydrolyzed. So when we have the ester, we can undo that, right? We can stick the water back on. We need to have the presence of some kind of an acid or a base in order to kickstart the reaction, get it to go. It won't really work at a regular pH, but if we do that, then we're going to take water, we're going to break the water, and we're going to stick half of that water on each side. And I think this really kind of highlights, right, that we talked about acids and bases where hydrogen was H+, hydroxide OH-, and that really is two halves of water. We're sticking one of those on the fatty acid and another one to reform the alcohol. And in doing this, we're undoing that dehydration reaction we did previously, and we call this a hydrolysis reaction, right? Through addition of water in an acidic, shown here, or could be basic environment, we'll see that later. We break down the ester. Hydrolysis as a word means hydro, which is water, and lysis is breaking. We often talk about lysing cells, which means popping the cells, right? So breaking via water, hydrolysis reaction, hydrolyzing this wax to break it down. That's all stuff that we'll see, that we are seeing here in this course. But moving forward, let's talk about glycerides, specifically triglycerides, because this is how fats that we think of as far as food fats, right, like olive oil and butter and things like that, as well as fats that's stored in us, right, they're in the form of triglycerides. And this takes that previous look where we're joining an alcohol and a fatty acid together to form an ester. This is going to illustrate how that reaction works and why this is like a nice convenient way to store fatty acids in the body. Glycerol, we'll see this molecule coming up. It's basically a 3-carbon alcohol. It's 3 alcohols linked by carbons, and the fatty acids are going to mount to this glycerol. And we see this little depiction of the triglyceride to show that it's basically 3 fatty acids stuck together. Remember that these are nonpolar, right? And this ensures that a bit better rather than having fatty acid polar sides drifting around the body, and is the way that we end up storing fats in nature, biochemistry. And so here's a look at that triglyceride. Again, what we've seen is that that glycerol has formed 3 esters. So if we look at this triglyceride, we can see 3 ester groups that are here. And again, that glycerol is this left side of the molecule. Imagine that each of those first oxygens has an H that are attached to it, right? OH, OH, OH. It's really just a 3-carbon thing that mounts, these fatty acids to it because it has 3 alcohol groups. And we attach the 3 fatty acids, and now you're basically carrying around 3 fatty acids that if you need to hydrolyze them, you could, right? Remember that we did the dehydration, and we can do the hydrolysis to free up these fatty acid chains whenever we need them. If we have different fatty acids, well, then we can do that, right? We don't always have to have the same fatty acid chain on a triglyceride. And here's an example where we have an unsaturated carbon chain that's on the triacylglycerol. And so, this gets us to saturated and unsaturated fats, because remember we talked about saturated and unsaturated fatty acids previously, but it really is these triglycerides that are the molecule that identifies what we know is dietary saturated and unsaturated fat. Fats are essential, right? Fats can get kind of a bad rap when it comes to energy storage. This is often the opposite of what we're all trying to do, but they are essential parts of nutrition and of biochemistry, and identifying them is important too, right? When we're looking at fats, saturated versus unsaturated fat is a really important part of dietary fat understanding, and something that as you go into healthcare could be really useful to be able to talk about with your patients, right? Saturated fats are linked to a lot of health challenges that unsaturated fats are really not linked to, and so while overall fat should be kept in moderation, whether saturated or unsaturated, within that balance of fats, it really is best to have more of the undamaging fats as your food source, right? If saturated and unsaturated are, one of them can be more challenging biochemically than the other, best to keep the unsaturated. And so finally, let's look at some food sources that have saturated or unsaturated fats in them. I think that a good general rule is that animal proteins that come with fat is typically saturated fat. So when it comes to cheese or butter, or fried foods often, but you could theoretically fry foods in unsaturated fats like olive oils, but definitely all that solid fat, cream, butter, the fat on meat that when it's, even in room temperature, like the fat on a steak is solid. These are all saturated fats. And unsaturated fats are, more liquid at room temperature. And, I guess the distinction of meat versus not meat is a little challenging. It is kind of confusing, to know which ones are saturated and which ones are unsaturated. But I would say that most plant sources are probably going to be unsaturated fats, with a few exceptions. And again, this solid or not solid at room temperature can help quite a bit. Remember as well that even when unsaturated, trans fats also behave like saturated fats. And so, when it comes to trans fats, there aren't a lot of trans fats that are around dietarily anymore. They've been removed for the most part from a lot of foods. But I would say that sticking to natural food sources will help you get away from trans fats. Trans fats often associated with highly processed foods, margarines, and things like, shortening and whatnot. So if you can use more natural foods, that'll go a long way towards avoiding trans fats. These ones are in foods like the following. And again, fried food appears on this list several times. What you're frying in is what is going to determine the type of fat, right? If you're frying in shortening, you're going to be eating shortening, and that's going to have trans fats. If you're frying in olive or avocado oil, that's going to be unsaturated fat. But remember that a lot of times the trans fats that are used for frying is done because it's, inexpensive and tasty. And so when you are eating fried food for which you may not know what the oil was fried in, it's probably not going to be like, an expensive, high quality dressing type oil like olive oil or avocado oil. Finally, I think that this chart is kind of useful for showing the breakdown of certain foods. As we've discussed, butter is an animal fat, it's solid at room temperature, it's mostly saturated fat. When we think about olive oil, it's a plant source, it is liquid at room temperature, it's mostly unsaturated fat. When it comes to plant sources, one notable example is coconut oil, and if you've used coconut oil, what you'll observe is that it's solid at room temperature. That's mostly saturated fat, and it is uncommon in being a plant source of fat that is actually mostly saturated. Finally, vegetable oil or margarine. When it comes to nutrition, moderation of all these things is key. It's not like you need to only eat unsaturated fat and that's it. But when it comes to fat sources that are primarily saturated fat, it's worth it to take a second look at whether this is necessary, I suppose, or whether it could be substituted with a healthier fat. And if it can't, well, just try to use as much moderation as you can. This is easier said than done, of course, for me and for everybody, but knowing what you're engaging in as far as the challenge can go a long way as far as setting yourself up for whatever success you define.